Hello and welcome dear learners to the NPTEL course on Healthcare Quality Management, Infection Control and Patient Safety. In the Module 5 Operational Excellence in Healthcare with Chapter 53, we will be dealing with the discussion on Effective Preventive Maintenance for Hospital Part 1. In the content part, I would say Introduction to Preventive Maintenance in Hospital, Hospital Engineering Services and Facility System, Preventive Maintenance Framework and Documentation, Medical Equipment Management and TPM, that is Total Productive Maintenance in Healthcare, will be dealt with. In Introduction to the Preventive Maintenance in Hospitals, engineering services in a hospital plays a vital role in patient satisfaction and hospital operations. As we have even discussed in the previous chapter, the importance of engineering services. Hospital buildings consist of civil assets, utility assets, and mechanical assets such as lift, dump waiters, diesel generators, and even uninterruptible power supply, that is UPS. So, for the smooth hospital operations, which depends on the periodic preventive and corrective maintenance of the engineering components. Preventive maintenance can be carried out in-house teams and outsource agencies, which is depending more on the resource availability by the hospital. A checklist-based practical maintenance approach helps hospital personnel to see the maintenance part. Hospital air conditioning is a specialized subject, especially for operation theaters and critical areas. Maintenance of sterile environments, HEPA filtration, laminar airflow and pressure, which is essential for infection control. So preventive maintenance increases equipment life, reduces the failures and improves safety, and it ensures even the continuity of the patient care. Hospital engineering services and facilities systems are listed over here, where you may find the water management system, which including the RO water, electrical power management system, DG sets and UPS transformers, heating, ventilation and air conditioning HVAC system, civil assets, fire prevention, detection and lightning system, medical gas pipeline system, MGPS, which we have even discussed in the previous chapter. Statutory and regular compliance, that is sewage treatment plant, effluent treatment plant and biomedical waste disposal. In the sewage treatment plant, we can say that hospital waste, that is liquid, can be categorized into medical liquid waste and domestic liquid waste. Medical liquid waste is collected from dialysis, OR, operation rooms and laboratory through a pipeline to a liquid waste treating plant, which is located before the STP plant. Medical liquid waste is normalized by using 1:1 hypo solution either automatically through the ETP or manually before it is let out into the normal sewage collection. All the waste water and sewage are to be connected to common sewage. The aeration pump will run for 24 hours a day, and the running hours of the blower and pump will depend on the type of STP. The bar screen chamber checking and cleaning is done and the raw effluent aeration is checked. The MLSS, that is a mixed liquor suspended solids, is always maintained at 250 to 350 mg per liter if the required divert excess sludge from the clarifier to the aeration tank to maintain the MLSS. The backwash should be done every day. The treated water is always chlorinated before being let into the final water tank. The hospital should use the treated water for the landscaping. Water can be used in the flush system by doing ultrafiltration, which is a green method termed as zero discharge. The total plant overhauling and cleaning is to be done every year prior planning. This exercise includes replacement of media. Proper preventive maintenance, that is PPM, of the electrical system in the STP is to be done. A proper log shall be maintained on operation on daily basis, which is to be signed by the facility supervisor. The hospital shall ensure that the output of the effluent treatment plant shall comply with the pollution control norms. In this figure, as what we have discussed, the liquid waste control and pre-treatment, main sewage treatment plant process and post-treatment disinfection and reuse being shown over here. With respect to compliance and pollution control norms, we need to have a proper maintenance and treatment system. Now, with respect to diesel generator sets and uninterrupted power supply, if there is a power failure, diesel generator should be equipped with an AMF, that is automatic mains failure panel. due to which all the disruption panels will get the power within 25 seconds, which is very important for those conditions which are more dealing with critical and operations. The hospital should be equipped with enough UPS power back for a critical equipment like all the operating rooms, all ventilators and ICUs. CT scan, critical equipment and emergency lighting that will withstand a minimum of 20 minutes during an emergency. Every 30 minutes of the DG running, the facility technician checks the load current, diesel level and noise level. The maintenance of this is very important to prevent the premature wear and potential failure. Transformer must be loaded equally across all the phases, and you may need to ensure the safety parameters which are must very strictly monitored. A comprehensive yearly preventive maintenance is very important for this part. For outdoor oil-based transformer and remote tap change control system, regular oil filtration must be performed and maintain insulation integrity, which is very important to understand the importance of the maintenance of transformer, UPS and DG systems. Uninterruptible power supply UPS. All UPS systems have to check daily. Preventive maintenance has to be carried out as per the master schedule. The performance test, the detective batteries or all the batteries have to be replaced on the completion of the years with respect to the services which are to be ensured by the providers actually. The UPS area should be air conditioned. The temperature should be maintained between 22 and 24. The UPS area should be kept free from dust and loose wiring. And importance of this is that you need to work on the safety parameters which should be checked as per the standards. Diesel generators should also be checked and carried out as per the checklist. During A checks, the engine should be cranked at least once a day. During a power failure, it is suggested that DG should be run for a minimum of 30 minutes. So, the diesel generator should be loaded between 70 and 80%. Lube oil or speed diesel only should be used to run the DG set. So all these are to be emphasized to see that the check with respect to DG is carried out from the service provider. Load performance, panel board, areas which needs to be fueled actually are to be checked as per the standards. Run time hours, that is B check 300, C check 1000 and D check 500 should be ensured. Use of engine oil coming out of the DG shed should be handled over to be the authorized recycling vendors. With respect to hospital fire safety system, hospital should have a fire safety system mainly divided into two parts, that is category 1 and category 2. Fire detecting system and fire fighting system. Fire detection system is usually to detect the fire automatically in case of the fire to a building, example a smoke detector, heat detector and fire alarms. While versus in the fire fighting system, a firefighting system fights against the fire with or without manual intervention in case of fire incidents which happens. For example, a fire sprinkler system, a fire hydrant system, a public address system, manual call points and fire extinguishers, which are now a norm which are very much in taken for the incidences which are increasing. Fire alarm system. In the hospital, we should see the addressable fire detection system and fire detector should be installed through the building. Detector is divided into zone. One multiple zone detector on each floor should be there, and it also should have a spread above and below the ceiling. Multiple zones are connected to the panel at each floor and the floor panel is connected with the repeater panel of the lobby level. Now in this particular figure you can find the component 1, which is water supply and normal pressure maintenance, which is for the automatic fire hydrant, and in the figure 2 you may see the automatic emergency pump cascade logic, which is shown into the red, where the main fire line significant flow and which is showing the sprinkler part. In the component 3 below OA, the system outputs backup and manual setups actually for ensuring that the automatic fire hydrant system works on. Now for public address, it is very important that you need to give address to the public from intercom or ceiling speaker. During emergency, we should use any one of the internal extension phones dials or wait for a few seconds till you get a line activated. And once the line is through, announce the code type and detail the MCP to the staircase speaker. And you understand that during the emergency, if anyone break, activate the MCPs installed at the stairwells. If the smoke detector sense the fire, the zonal panel and the repeater panel indicate the location and give off the alarm actually to the stairwells. Locations where the fire system should be installed. It should be installed actually evenly and spread throughout the basement floor areas and car parking. The distance between two sprinkler ahead is 3 meter and fire hydrant points are installed at 2 points at each floor. Water storage of 1.5 lakh at the basement and 0.4 lakh capacity tank above the staircase. Manual systems probable for the fire extinguishers are provided throughout the hospital, and every employee should know, and the training should be given well enough actually how to handle and to maintain the fire extinguisher. All these fire extinguishers are served annually and have a service for this part indicating the date of service on it. The type of fire extinguishers are shown into this particular figure, where the class A is for ordinary combustibles such as paper, rags and wood. Class B is for oil, flammable solvents, gasoline, greases, inflammable and gasoline, LPG and CNG. Class C is for electrical fire. Class D is for metallic fire. Class on the types of extinguishing, that is pressure, water for the class 1, the dry chemical even for the class 1, and even dry chemical can be used for the class B. Carbon dioxide uses class B and class C fires, chemical foam used for type B fires, and hose reel or other type of systems are in adjunct used for fires and extinguishers. Hospital fire prevention plan, which is being shown over here, with respect to the wastage and storage management, you need to be very important that storage inflammables are more from the removed paper, cloths and waste daily. Keep away from heat and spark sources, all these materials. Electrical safety with respect to no smoking policy. Periodical check all the electrical appliances and defects. Do not use multi-socket attachments and do not repair faulty appliances direct to facility part actually. Fire safety equipment and training is being emphasized over here, where place fire safety equipment is accessible place and check it periodically. All staff must learn to use the fire safety equipments. Emergency exit and lighting, where the emphasis on the signages, emphasis on the exit plan, and with respect to planning, ensuring the exit route are not blocked, and the planning part also emphasize on giving the directions for the fire exit. Medical gas pipeline system, MGPS actually, which is being shown into the picture with respect to the normal operation automatic changeover, where the stage 2 emphasize more on the safety and cylinder change preparation from non-smoking to identified empty bank and control panel, which is being highlighted with the colors, yellow being shown as standby running, right being shown as right hand empty and left hand running. So stage 3 emphasizes more on the step by step cylinder replacement procedure, which is highlighted as first as isolate, then disconnect, replace, reconnect and restore, which is very important to understand the emphasis of medical gas line pipeline system, which is being shown to emphasize that how you need to work on the operational part of this. Compressed air quality. One of the most stringent requirements for compressed breathing air today is found in ANSI and EPA 99, a regulation for safety requirements for medical compressed air and vacuum system. Not only must the air meet the limits set by the regulations, but continuous monitoring for dew point and carbon monoxide is also mandated. Electrochemical sensors are quite specific and have a long life today, up to 3 years, for detecting the carbon monoxide gas, and are commonly used as detectors in the state of the art instrument. In addition, the pressure dew points probes are readily available using the lift crystal, chilled mirror or thin film solid state moisture detection techniques. So the air test requirements are being shown into the figure over here. Heat ventilation, that HVAC, the hospital needs to be equipped with three systems or three types of air conditioning system, that is air handling units, fan coils units and package units. And isolation rooms for infection disease, they need to be maintained that isolation needs to have a negative pressure for approximately 2.5 pascals. A manometer should be installed outside the isolation room for display and monitoring. An isolation room ideally should have an anteroom. and exhaust from such a room should be taken to the roof level, and the same should be available for ensuring in the toilets also. The figure here depicts the suggested guidelines for air conditioning for operating room, operation theatre and air systems, where it is being shown in the model 2 the dedicated AHU, and even the model 4 it is showing the validation and maintenance cycle, which is being shown that the OT room environment and airflow dynamics positive pressure of plus 2.5 Pascal being shown, and this figure also points to how to ensure actually to give the air conditioning of operation room more emphasis on. Now, for the preventive maintenance framework and documentation part, it is very important that the preventive maintenance is defined as a physical checkup of system and then can increase their life. Hospital preventive maintenance is categorized into preventive maintenance of the rooms, where the preparing the master list of all the patient rooms has to be planned up in such a way that the preventive maintenance monthly wise in that room should get at least 3 cycles in a year. 3 months of the data should be compiled regarding the problems or complaint faced by the relevant departments which are coming to the heads. All the light fixtures will be removed and handed over to the support services for cleaning and maintaining park. Public area needs to be emphasized of having a facility for the support services will prepare the master schedule for all the public areas with respect to monthly schedules and even the weekly schedules. Preventive maintenance of public toilets will be cared of monthly. Preventive maintenance for the kitchen is emphasized by monthly checkups actually for those areas and complaints coming from those, while the checklist will emphasize more on the equipment parts to ensuring the compliance actually to met up, and if at all there is a requirement, engineering facilities, support services and operations need with respect to the quality managers work to ensure the standards audit checklist of this. Preventive maintenance for engineering utilities. Facilities will prepare the master schedule of all engineering equipments, all department as applicable, and they will work on the preventive maintenance part. Department will forward any complaints which is coming to with respect to equipments in advance, and the preventive maintenance will be carried out as per the checklist for each equipment. The Green Hospital Initiative framework is being posted over here for this particular figure, which shows that the importance and emphasis of green is very important nowadays with respect to choosing the environment and the designing part of sustainability and efficiency. With respect to the material and construction phase, you need to incorporate the recycled material, use green compliant material and source from the India Green certified units. With respect to the system and operation phase, you need to recycle the water and you need to emphasize on the strategies which ensure the installation and calibration, establishing waste separation and recycle program, which will give you on the part B that the facility engineering quality indicators should to be ensured when it comes to the metric 1 downtime of the equipment, metric 2 of the preventive maintenance planned versus the actual, and metric 3 with the response time for the complaints, which is very important for the Green Hospital Initiative framework to be installed in your hospital if the hospital is more towards the sustainability initiatives. Documents to be maintained. To develop and implement the maintenance schedule for all critical zoning, you need to ensure that patient safety room, dietary services, public areas and essential utility room to ensure the operational efficiency and safety. The checklist needs to have a generator, boilers, AC plant, ambulance, fire safety, STP, chiller plant, air compressor and vacuum pump, LPG bank and pump room checklist needs to be maintained, and the monthly checklist with respect to low tension panel, UPS system, daily checklist of all facility units. So you can understand the importance of monthly, daily and weekly checklist over here. With respect to medical equipment management, medical equipment manager has gained a prominent role now in a successful running of a hospital. With respect to efficient management of medical equipment should cover technology acquisition, acceptance of the equipment in the critical areas with respect to initial inspection followed by training and risk management of that. A routine performance training is very important, and maintenance is one which is no doubt comes with repair, maintenance cost and replacement. So most of the points which are covered in the national accreditation standard like NABH and JCI are emphasized over here, and with all the biomedical engineers efforts you can responsibly give up a better solution to the medical equipment maintenance. And you may even understand the user's acceptance on the part to collect more inputs to improve these facilities. The acceptance of medical equipment. Acceptance in the clinical area should be based on a detailed check of all technical features which are at installed equipment against which is aggrieved by the service provider. So verification of all the hardwares and application software by the use of the user with respect to the biomedical engineering team. Equipment should be adopted in the clinical area only after comprehensive training. I emphasized over here for the training part, which is very important, that the medical equipment is very much important to be taken in maintenance with respect to verification and validation of the results on volunteers before the actual patient use. Because sometimes the result may be different when you are using on the patient versus when you are treating it in your actual services. The medical equipment acceptance checklist is being shown over here, where I want to emphasize more on the equipment delivery and vendor notification, which is very important when you point out the vendor rectification, revaluation, and you get all the acceptance with respect to general information, item verification, documentation, training and safety part, maintenance, and vendor support. The technical test actually is also very much when you work on the medical equipment acceptance checklist actually, which is very important to give you all these clarifications before you go up for a vendor selection. So, and the condemnation of the biomedical equipment is also where you emphasize more on the condemn policy or how your hospital is working on the condemn. You need to have a meeting for that, evaluation criteria needs to be done, and the condemnation decisions actually be taken whether it is yes or no. If it is yes, process condemnation and disposable, and if it is no, retain, repair and usable from those documents, because most of the hospital deals with this with the lack of no policy for that, or you need to review on what was there previous and what you need to do it in the later part. Now, finally, for the total productive maintenance, that is TPM, of the hospital-based biomedical equipments, you need to understand that the TPM is a lean equipment maintenance strategy, which was introduced by the Japanese company called as Nippodenso in 1971, which works more towards improving the quality part. And the objective of this TPM was maximize energy engineering plant and equipment effectiveness, maximize engineering plant and equipment effectiveness, which aims at economic effectiveness and optimum life cycle cost. The reason is that to improve the economic effectiveness, you need to have an total productive maintenance, which is more towards the philosophy of total quality management. The TPM integrates zero defects and zero breakdowns and zero accidents. So with this, you can see that medical equipment utilization and maintenance process flow, which highlights actually the daily user care and handling, which is more from the start equipment use at the first level to see the perform daily care, which is more from the cleaning, disinfection, sterilization, infection control guidelines, including the accessories also are highlighted over here. The equipment functional part, if it is yes, you can go ahead with shift wise handover and documentation and continue the utilization, which is shown into the cycle over here. If it is no, then there is no place for non-functional sticker reporting the snack promptly. Where it is very important for us to understand when you are working on the medical equipment utilization, and when you come across the utilization review and management plan, you need to work on the management reviews and utilization report, may be coming from the cath lab, endoscopy or other units. If it is in the very right way, actually you need to assign the responsibility for shared equipment to one department, and the department will perform the calibration, ensure the continuation of the proper operation plan, and they can even schedule a preventive maintenance meeting actually, which can ensure to give us, if it is yes, you may go up with accreditation guidelines meeting updated stickering or updated equipment history, which also give us the importance of maintain all services logs and spare replacement records, which is very important, and a reward and recognition for minimum maintenance cost and no untowards incidents, which gives more a benefit as a motivation. So you can understand the medical equipment utilization and maintenance process flow, which is emphasized into this figure, and which gives us a clarity on understanding how you need to work on the daily users versus utilization review, maintenance, and versus to a maintenance and documentation, which is more for the PM and calibration, which gives us a clarity on how you need to work on this. So with this, we come an end to this chapter. Thank you for your patience listening. You can take up this references, you can work up with the chapters discussion on improving the projects that you are taking for the discussion for your hospital and your committee for the maintenance part for this. So with this, I come an end to this chapter's discussion. Thank you.